It's okay. Good evening and greetings wherever you are. Now let's look at hypothesis testing. Usually, a hypothesis is just a guess, a scientific guess that you can actually use data to prove whether you are right or you are wrong. For instance, somebody can estimate that the average height of all nurses in Ghana is around 4 meters. I mean, we can subject that to proof by just picking some random nurses, measuring their height, and then we simply calculate, and then we try to prove whether this hypothesis is wrong or it is right. Somebody can estimate that the average water pressure, what is it in Ghana here, is actually maybe higher in Accra than it is in Kumasi. So we can pick the average water pressures in the two places, then we pick and then we try to compare them, and then we can also do what we call the test the hypothesis and to see whether this is right or wrong. Now let's get to our studio and look at how this works. So I have already, okay, so I just have some hypothesis testing in R, which I have here. So I'm just going to create more space around here, then I push it a little bit, then let me come here like this. So I decided to create some samples here, and then so I just use the sample function to create this, about 100 of them, 100, 100, 100, and then I decided to create a data frame called nurses. All right, and so this particular data frame, if I should, let's say, print it, you can see there are quite a number of them. Yeah, so we are looking at the the weight, the height, the salary, and then the attendance. So at this point, I would like to ask, or I'd like to answer the question, whether if the average, let's say, weekly attendance of nurses to work is up to 5 times. So we can say that we can set our hypothesis that nurses weekly attendance to work is just 3 or something like that. Or we can check their salary. We can say that the average salary of a nurse in Ghana is around, let's say, 2,000. So that can be our hypothesis. And then let's try to do that. So now, if I do a head, just run a head of it, you can see that I have that seated over there. Let me run that again so that you can see it clearly. So you can see that we have around here. So this V3 is actually the salary option, but I decided I have to rename it. So let me run the renaming, and then I run the head again so that we can see the names there. So we can see the salaries are here. And so, but I am going to use one-way sample using the t-test. I'm going to use the one-way sample using the t-test. And we know that when we calculate and the t-statistic is more than or is greater than the t-critical, then what happens is that we simply reject the null hypothesis. In any case, when we also realize that the p-value is also way lower than the whatever percentage that was given, then we also reject the null hypothesis. So here, what is our hypothesis? We are saying that the average salary of a nurse in Ghana. So let me state it around here. And so what we are saying is that the average, so the null hypothesis, let me just put it this way, H0 or H0, the null hypothesis, we are saying that the average salary is saying that the okay, so average salary is equal to, let's say, 2,000. and then the alternative will be something different. So HA will be equal to, or will not be equal to. So I will just put this one means not equal to 2000. And so what we have to do again is to simply make sure that now the sample size are about the sample size about 100 in all. For instance, if I should do a structure, what is it? The structure of nurses. You notice that there are about 100 observations, as you can see here. But because I'm using T statistics, I need to deal with a small sample size. So what do? I need to split the data, or I need to sample only 30 from there. So what I did is to just create this particular small vector, which I say 1 to 30, and I put it over here. So now when I come and I use the nurses as a data frame, then I will just go into the rows column, and I say that it should pick from row 1 up to row 30, and then pack it into something we call the nurses underscore new. And then when I run that, you see that, yeah, I have created. Now, if I should look at that one, you see, or if I should look at the structure of that one, you will notice that the observations will be 30. So let me run that, and you can see that the observations are 30. And I'm doing this because I want to use, let's say, t-test. So here, the null hypothesis I am saying is 2000. And then the alternative is saying that it's not 2000. So that's what we are going to test. And so what do? We need to create our sample size, and then let me show us this particular slide. So if you look at this, is how we calculate the T, or we are able to estimate our T statistics. So the T is equal to the X bar minus mu. This mu here is the average that you have already given, that is the 2000, and here is the sample average, or the sample mean. And then here we have our standard sample standard deviation, and of course this is our sample size. And so let's go back to the studio and see how we can we can code this. So when we come here, we need to create our sample size. So it's the same thing as n row of the data frame, which is nurses underscore new, and I'll pack that into n. Okay, and so when I do that, my n is there. And here we are looking at the mean that was given. The mean that was given is 2000. Okay, and then our degree of freedom is always the sample size minus 1. So n here, which is our sample size, minus 1. And so I can also run our mu, which I will call the capital U, and then I can run my degree of freedom. So to calculate my X bar, I'm just going to find the mean. That's the sample mean. But the sample mean, I am looking at what? Salaries. So I'm going to just do this, and then I'll put the salary. So you can see the salary is there. And of course, if I come here to, it's the same thing. I'm just going to do this and select the salary column, because I'm actually not dealing with the rest of. So I'm going to run this. So it will calculate my X bar for me, then calculate my sample standard deviation. And now what I need to do is to calculate the T statistic. And to do that, you just have your X bar, which we have already calculated, that's the sample mean, minus the mean that was given. That was the estimate, that the average salary is 2000, so which is mu, capital U here. Everything divided by the standard deviation, which we have already calculated, and then also divided by the square root of what? N, the sample size, which we have it here. So we're going to calculate that, and then our T statistic is ready. So if we want, we can print the T statistic here, and then we see what is there. So our T statistic is actually 4.76. That's what our test statistic is saying. But we need to compare this to our T critical. And then to calculate our T critical, mostly there is a table where you can actually read this value. But if you don't have that table available, for instance, you can actually just Google and then you will have that particular table where you can correspond the T critical value. But if you don't have it, you can calculate it using this small this equation. You can use this function called QT, which is equal to P, and then you see that we were doing this at 95% confidence interval. So because it's 95%, we are assuming that we are given a grace period of, let's say, 0.5 or 5%. And so if you divide 5% by 2, you're going to have 0.025, and that's why we have P is equal to 0.2. And then our degree of freedom is always the sample size, which is 30 minus 1, and that's why we have 29 here. And so when we do that, we can calculate this, our T critical. Yes, but I also prefer this. This one is a two-way, but because this one is one-way, maybe this one, that's the two-way. If I were dealing with the two-way, the calculation, I would have been, but this is the one-way. So I'll leave my T critical at that particular point. So let me print the T critical, and you see it's actually minus 2.045 and then something. And then we also need to calculate our p-value. Our p-value is usually 1 minus pt, this function of the t statistic that we have already calculated, and then combined with the degree of freedom, and that will give us our p-value. And so let's calculate that, and then we print our p-value, and then see. And so our p-value is actually 0.0024 something. As you can see, it is 2.4 raised to the power minus minus 5. So that's around 0.00002. And so once the p-value is lower than the 0.5, or is is actually way lesser than 0.5, then we can say that we reject the null hypothesis. And so what are we rejecting? We are rejecting the null hypothesis, which we stated that the average salary of a nurse in Ghana is actually 2,000. And so if we are rejecting the null hypothesis, what are we doing? We basically have to we have to conclude that the average salary of a nurse in Ghana is not actually 2,000 Ghana cedis. And that is what all this is all about. Now, there is the easiest way to be able to do this. The easiest way is that the t.test is a function by itself. So what I would have done is just like I could have just done it this way. Let me type it for you to see. So I could have just used this function called t.test, and then I put into bracket like this. So what am I calculating? I am calculating nurses, but this is the new one I'm looking for. But I'm looking at I'm looking at the salary. I want to find out the t statistics of the salary, and then the next thing I'm looking at is mu. The mu is the average salary that we have estimated, which is 2,000. Yeah, and then when we do that, we just run this at once, and then it's going to print a whole lot of information for us. So as you can see, our t statistic, or our t calculated, is actually 4, and then our degree of freedom is 29. Our p-value is actually the same thing like we have here. Well, I don't know what happened, but the p-value is a little bit different from here. So we have our p-value, which is here, and then we have our alternative hypothesis. It's saying that the true mean is not equal to 2,000, and this is very important. Here, that's where you can actually drive your conclusion from. So it is telling us that the true mean, or that means that the actual average salary of a nurse in Ghana is not 2,000, and that's exactly, you can say that, and you have estimated this, or your calculation is based on 95% confidence interval. and that is what we have down here. And then that is it. We can also see our our sample estimate, and then the mean of x, which is actually here, and then which is actually 2,604. So what it means is that the average salary of a nurse in Ghana is around 2,604 Ghana cedis. So here, when you use the easiest way, I just follow the step by step for us to be able to see how this is being done. But when you use the easiest way, where you just use this particular function, the t-test, and mostly you go into the data frame, you pick up the column where you want to calculate you want to estimate your t statistics, and then your mu. The mu is actually the average that was given to you, and then the rest of the parameters has already been found in this particular function, and then you are good to go. And then that is it. Then you have all this information there. You can print this information, and then you can make sense from it. So this is how we calculate, or we are able to do hypothesis testing. This is one way. I'll come around with the two-way and then the paired way, and then in different videos for you to see how it is being done. I wanted to also illustrate how you can actually do this on a whiteboard, but maybe I'll do that in a separate video. This one is quite becoming longer. Thank you. If you enjoy my videos, why don't you share, like it, and then subscribe to my YouTube channel, and together we can just be doing this. Thank you. I'll see you in another video.